Hello, and welcome to this presentation, Understanding DTMF. In this presentation, we'll explain how DTMF is used in radio communications and how DTMF signaling is tested. DTMF stands for Dual Tone Multifrequency and describes audible tones which are the combination of two different single-frequency tones. Each multifrequency DTMF tone is assigned either a number 0 to 9, a letter A through D, or the star or pound symbol. Note that the tones corresponding to the letters A through D are rarely used. This type of signaling is most widely known for its use in telephony and so-called interactive voice response systems, where the caller is prompted to press keys on their phone for different menu options. You may also hear these tones referred to as touch tones, particularly in the United States. But in addition to being used for telephony, DTMF tones are also commonly used in a variety of ways in two-way radio applications. In the remainder of this presentation, we'll explain how DTMF tones are used in this way, how they're generated, and how they're tested. Let's start by looking more closely at three application areas of DTMF in radio communications: selective calling, radio management, and remote control. We'll start with the most common of these applications, selective calling. The primary use of DTMF tones in radio applications is for calling or addressing only certain receivers. The receiver is configured not to break squelch unless it receives a configured pattern of DTMF tones, in most cases between 2 and 7 digits. These digits may be sent manually, that is, the user enters the digits each time, or the radio may be configured to transmit digits automatically at the beginning and/or at the end of each transmission. One important thing to note is that tones may be used to identify the radio transmitting the tones, or they may be used to indicate the receiving radio or intended recipient. DTMF-based transmitter identifiers are sometimes referred to using the acronyms ANI for Automatic Number Identification, or PTT, that is, Push-to-Talk, ID. A related use of DTMF is configuring or controlling some kind of radio or radio-related system, the most common example of this being two-way radio repeaters. DTMF tones can be used by the repeater owner or administrator for the purpose of configuring or managing the repeater, especially for repeaters that do not support Internet or telephony-based access. Some repeaters may also require an authorized ANI or PTT ID in order to access the repeater. And for repeaters that are part of a system of linked repeaters, DTMF is often used to select which repeater to link to. Because DTMF is also used in telephony, tones can easily be used to interface between radio systems and telephone systems, although this type of connection, or auto patch, is much less common than it once was. One other aspect of radio management is where DTMF is used to implement remote stun, revive, or kill. Here, DTMF tones are used to disable a lost or stolen two-way radio. DTMF can also be used to remotely control non-radio devices. There are many examples of this, including activating warning sirens for tornadoes or other weather-related events, opening and closing railroad crossings, commanding high-altitude balloons, etc. General-purpose adapter boxes and/or interface boards enable DTMF-based control of almost any type of connected device. There are also several different ways of implementing access control, or security, in these applications, such as the use of password codes, non-standard codes, licensed frequencies, lockout timers, etc. Now let's look more closely at the tones themselves. As mentioned earlier, DTMF tones are actually two audible tones, which are sent simultaneously at different frequencies, but with similar amplitudes. Here is the standard DTMF tone table. To make a DTMF tone, we'll pick one tone, in this case 770 Hz from the column on the left, And then we'll pick another tone from the row along the top, here 1336 Hz. When these two tones are combined together, we get the DTMF digit 5. The main reason for using a combination of tones is that this reduces the probability of false detection, or falsing. Note too that these standard DTMF frequencies were chosen such that none of them is a harmonic of another, and this also reduces the possibility of a false detection. Lastly, although the vast majority of DTMF tones use the frequencies shown in this table, it's also possible to create DTMF tones using a combination of two arbitrary frequencies. DTMF in two-way radio applications is typically tested using a radio test set, with the radio or device under test connected via cable to the test set. Tests can be divided into two main categories. The first is using the test set to generate a modulated carrier and then to insert user-defined DTMF tones onto this carrier. This is done in order to verify that the radio or device under test behaves properly upon receiving the tones, for example, breaking squelch. The other aspect of DTMF testing is measuring and analyzing DTMF tones generated by a radio. In this case, we're primarily concerned with the frequencies and durations of the transmitted tones. One advantage of using a radio test set is that it can test using both standard and user-defined tone arrangements, and it provides the highest flexibility and measurement accuracy for both frequency and timing. Let's end with a brief summary. DTMF stands for dual-tone multifrequency and is a very common type of tone-based signaling used in two-way radio applications. There are three primary application areas for DTMF. The first and most common of these is selective calling, which enables radios to receive or break squelch only upon reception of a defined series of DTMF digits. Another application is controlling or managing repeaters or individual radios. A less well-known but equally important application is using DTMF to remotely control non-radio equipment, such as tornado warning sirens or railroad crossings. On the technical side, there are 16 standard DTMF tones, 0 through 9, A through D, star, and pound. Each of these tones is a combination of two single-frequency tones. And finally, we briefly discussed the two main ways that DTMF can be tested using a radio test set, namely, sending DTMF tones to receiver and verifying proper response, or analyzing DTMF tones generated by a transmitter. This concludes our presentation, Understanding DTMF. If you'd like to learn more about DTMF, other types of tone-based signaling, two-way radios, or radio test sets from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.